Hello.
Hello.
I think we are live right now. Um, Maybe if anyone's there, I think 9 people. You can talk with us in the chat. So hi everyone. Thank you for joining us tonight because it's night here in Croatia. My name is David. I'm the owner and co-maker of the Inkplate display, and with me is Borna.
Hello.
He was the main engineer in progress of making the Inkplate. So he worked in both hardware and software, especially software. Um, Today, on today's live stream, we are going to demonstrate the possibilities of an Inkplate. So we are going to show the hardware as well as software, go through some examples of using the Inkplate. We are also going to show how to do some specific stuff like show image on the screen, get some data from the internet and show it on the display. We are also going to show some of our future versions of the Inkplate boards because we are planning on making a whole series with different screen sizes and such. And finally, we are going to answer all questions that we have received so far. So for the start, I'm going to give a quick overview of a hardware of Inkplate. So as you have seen on our crowd supply page, we are currently funding the Inkplate. So at this moment we have 225% funded and sold total 231 displays, which is actually now showing on the Inkplate as well. So there's 3 weeks left. If you went through the campaign page, you have probably seen some stuff already, but I'm going to demonstrate them again in person. So Inkplate is a small maker-friendly device which is designed with simplicity in mind. So it's made to be extremely simple to use. For beginning, on the front side of the Inkplate, there is a big e-paper display or e-ink display. Which is 6-inch in diagonal, and it has 800 by 600 pixels resolution. There are also 3 touch buttons which you can make use of by making a menus or doing some actions for your code. So the main idea of the Inkplate is to make hardware and software very simple to use. So the hardware is simple to use because everything is on a single board, and it's just plug and play. You take your USB cable, just plug it into the board, and it works. So on the back side of the board, you can find the controller. There is a power supply, some additional circuitry which you need to which you need for the board to work properly. Also, there's a USB for programming and power. There's also a lithium battery charger as well as standard battery connector. You can find the micro SD card slot, so you can put your images, which can be loaded into the, which can be shown on the display very easily. There's also a power switch, and as I said, everything is made to be compact and extremely simple to use. So if I want to power the Inkplate, I'm just going to plug in the USB cable and put the switch to on position, and it starts working. So about the hardware, that's about it. So the main point is made to be very simple to use and durable, very short time to set it up and make it working. So Borna is now going to demonstrate you Arduino examples for the Inkplate. So I'm giving the word to him.
Thank you, David. Now I'll show you how really is easy to use the Inkplate, our Inkplate library. So the whole library is based around Adafruit I don't know if you ever heard of it, but it's the most popular Arduino graphic library, and it's very easy to use. With just one line of code, you can draw everything on the display. So let's get started. We'll fire up Arduino. So just a second. Okay. So here we have our example. You can find our library with examples on our GitHub page, and where you can download it and install it on your Arduino IDE. So we will start by the first line. First line tells us to include our inkplate.h library. So this is the library this is the file that contains all our functions to make our display work correctly. Order 3 includes our pictures that will be shown on our display. So these are grayscale pictures. In the next few examples, I will show you how you can program your inkplate to show grayscale images. So how you can convert your bitmap image, JPEG image, into a bitstream that will be recognized as a picture, grayscale picture on ink display. Next, we have a library for low power. Just copy, don't bother with this. Next, we have how many microseconds how many seconds we want to use our inkplate in deep sleep, because the main point of our inkplate is also very extremely low power consumption when it's in sleep. So it's about 20 to 25 microamps in sleep. So we're going to demonstrate how it's working in this example. Next thing is our inkplate object. I advise you just to copy this thing. You can call it you can call this object wherever you want, but it's easy just to copy and use display. Next, we have a selection of modes. So our inkplate currently supports 2 modes. First, it's 1-bit mode, where you can just use black and white colors, and the second mode is 3-bit mode color. So in 3-bit color mode, you have a variety of gray colors, or I would say one is black, second is white, and you have 6 of grading of gray color. First, in this part of code, you just say which mode you want to start your inkplate. So we want to start in a 1-bit mode. These are just data arrays for our pictures, for our bitmaps. So again, we will make a second. We will make an example of how to use this, how to convert. So I won't show you right now. Next is setup. So here we have one line of code that powers up the ePaper display. But this is old version of library. In newer version of library, the ePaper display is powered on right away when you start displaying image on the display, and powered off when you are done displaying the image. So you don't have to use this. But this line of code is very important. This line of code basically initializes your library. Without this line of code, your library won't work. Because in this line of code, you basically prepare the whole library to work with your display. You making memory for your data. Basically, you're doing dynamic allocation of memory for a frame buffer. So it's very important to not forget this. And now we're going to show you some real examples how to write something on the inkplate. For example, if we want to select text color, for example, you don't have many options to choose in 2-bit mode, but you have on 3-bit mode more colors to choose. But because we are in 1-bit mode, you can only choose black and white color. So we say, well, okay, we want the text to be black color, but the background of the text we want to be white. Next is the set text size. So you can scale your classical 7.5 pixels text to be much bigger. We want to be 2 times bigger than normal, so it will be 14 times 10 pixels. Next, we have a set cursor. So set cursor function tells us where we want to put our text on the screen. In this example, we want to be in 0, 0 position. That means in right upper corner, right left corner. So in this position. So this is 0, 0 position, and this is the last coordinate. I think 799 by 599. This one. Next, we're going to print. So Arduino, our library uses classical Arduino print print class. So you just type display.print, and you can write whatever you want in this function. So we write this whole text. Okay, and basically this just repeats for all of them. So we just set cursor, so we set position where we want to print the specific text, and we print the text. Next we have some more advanced stuff, for example drawing the pixels. So draw pixel function tell us where with the draw pixel function you can set wherever you want to drop the pixel on the screen. It takes two parameters. First parameter is x position, then y position, and the color of the pixel. On 1-bit mode, it can be only two colors, black or white. Now we have a line. So line has a more, I think five arguments or parameters. First two are start position of x and y. So when you're drawing a line, for example, on the screen, first and last position will be first x, first y, second x, second y. And the last parameter is, of course, color. Next, there are examples how to write a rectangular. Again, same principle, x, y, width, height, and color. So they're basically the same. You can all find all of these functions in Adafruit PDF, Adafruit GFX PDF. Now I'm going to show some a little more advanced stuff. Yeah, you can choose, for example, you can choose display mode 1-bit, and in the same program you can switch over to display mode 3-bit, and also again we can come back to 1-bit. So you can, in the same program, you can switch the modes of the display. Okay, basically these are the same like before, you just changing to color. So color can be great from 0 to 7. This is our library where we experimented to 4-bit mode, and 4-bit mode still is not so good. It doesn't give us the great picture quality. Okay, now I want to show you how easy it's to just write the picture that will be on the whole screen with our library. It's just this piece of code, this line. So this line, first argument says where you want to put, again, coordinate of the picture. We want to put it on the start of the screen, so 0, 0 coordinate. Second is where you, what kind of picture you want to display. Our picture is called picture 1, bit 1, so we want to display that, and resolution of this picture 800 by 600, and that's it. With just this line of code, you basically draw the picture on the screen. At the end, you have to, before you send this data, so everything you work, it's in RAM. So you didn't send this, you really didn't send this to display. So everything is RAM, but when you're ready to send the image to the display, you first have to clean it. So this is very important. If you don't clean the display and you send the data or the image to the display by calling display, you will burn up the image in the display and you can damage it. So always do display.clean and then display.display. Display.display basically reads whole RAM buffer, so your whole data, everything that you write into memory, and send it to display. So without this piece of code, it won't display you anything. So this is the basic functionality of our library. There are, of course, many things that are also available, but these things are more related to Adafruit GFX, and you can find many more stuff in Adafruit GFX manual.
Okay, I would just like to add one thing. So everything that you have seen right now, it's based on Adafruit GFX. So that means that some old code that you write for some different display or something, you can very easily implement it on an ink plate. So basically, without changing your code, you can put the same code to the ink plate because it's completely compatible. and or maybe with some very little changes. But the whole base of the code, it's the same. So it's a very useful feature, and it's also going to be useful for other versions of the Inkplate. So you can switch between them with doing almost no changes.
Yes, maybe only they have to set up the resolution, because many of the screens are used in Arduino are not that big resolution. I don't know. I think the monochrome, classical monochrome displays are 300 something.
Yeah. So Inkplate has a pretty big resolution,
Yeah,
so that's why.
yeah.
But in its core, it's the same thing.
Yeah, it's the same. So yeah. Okay, this is the example about how easy it's to use. Now I'll show you how to convert the image, so bitmap image, 1-bit or monochrome image, or grayscale image into this thing.
Okay, maybe we could before upload this code and show
Yeah,
people.
yeah,
how
of
that's-
course, of course.
Can we use this display?
Yes, of course.
Okay.
Problem.
So
We have this is an older version.
okay, so we are having the prototype here. So we need to connect the programmer, but the actual version, which is going to be received in with a campaign, it has a USB converter. So this display, it's all display. So
Okay.
so in Arduino IDE, the setup is also very simple. There's almost nothing that you need to do. Okay, so in a tools menu, you need to pick the proper processor. We are going to prepare the Inkplate board package, so you just need to pick the Inkplate here, but right now it's ESP32, so that's one that's picked up, and you of course need to pick the serial port.
I just want to say something. Few of people are asking us. They have a problem that image won't show, or even ESP32 won't boot when they try to use our example. That's the reason you have to choose or ESP32 rover module, because by using a rover module, you are basically using external RAM. So as you can see, we are using not ESP room, but ESP rover, just because of the external RAM. So you have to enable that RAM. So you have two options. You can go to this ESP32 rover module, or you can use ESP32 dev module, and then go to tools again, tools, and go to PSRAM and enable it. So these are two options. Why you want to choose the second options? Because you have more settings that you can tweak about. So.
Yeah, but that's something you don't need to worry, because it's going to be all in one. Just pick Inkplate and it works.
Yep.
Okay, so while we were talking, the code was uploaded. So right now you can see the first page. So this code is organized like a switch case, which changes every 20 seconds, and in between the Inkplate is in a sleep mode, which is, as Borna mentioned, very efficient sleep mode with only 25 or so microamps. So you can actually power this thing with a battery for years practically. So you can see actually the whole Adafruit library working at the moment. So the first page was 1-bit mode, when everything was either black or white. On this second page, you can see actually grayscale working. You can close it up a bit, so you can see those triangles in a different shades of gray.
I don't know how good is. Circles are not that great. Maybe I have to put blue.
Okay, you can see on this page. Yeah.
You can see this page, grayscale. So these two images are basically grayscale bitmaps. So you can also put small bitmap images like icons.
So this was realized with just one line of code. This one here, so it puts a random position the image one. And finally, the last case in our switch case, it's a bitmap image of a street. And it's also this line that Borna has demonstrated, and it uses the array, which we'll show you right now how to create for your own image. So that's what Borna is going to show you right now.
Yeah, I just want to show you. David mentioned that it's very low consumption, and you can power it from the battery, for example, we have a project right here. It's maybe a little bit all over the place, but it's a weather station that runs on just a single lithium-ion battery. I think it's a 700 milliamps, and it's now restart. Crashed. Okay. So basically, you can power this thing from simple little battery, which is charged by the solar cell, and it will last for years. I use it every day, this thing, and I've never ever have to charge it. I really don't know when I charge this thing by USB. So it's pretty amazing how little consumption this thing, and it refreshes every half an hour.
So the great feature of ePaper is actually that it uses power only when it changes something on the screen. All other time it doesn't need any power. So right here is a ePaper panel, which it's not connected to anything, and it still shows a picture on it. So no power is needed to show a picture, just to change it. So that's why you can use Inkplate with a battery for a very long periods of time. ePaper is efficient, so only uses power when changing, and the Inkplate is optimized for this kind of use because it's very low consumption sleep.
Okay. Now I'm going to show you how easy it is to convert the bitmap image. So when you find the image on the net, on the internet, or wherever you find the image, you cannot just put this image onto Inkplate, because this image is JPEG, bitmap, PNG format, and we currently do not support decoding of this format. So we have to convert from this format, this most popular format, JPEG, PNG, GIF, I don't know, GIF, whatever you call it, into something that Adafruit can recognize and can display on the screen. So first of all, we have to use something called LCD Image Converter. It's a free software where you can download it from the internet. Just type LCD Image Converter on Google, you will find it. It's free, it's easy to use, and I will show you how to do it. So you fire up your LCD Image Converter, you go to New Image, image name, doesn't matter, image. Then you go to Image, Import, and we go to Downloads. And let's try something that's monochrome, like this lightning bulb. I'm sorry. When you load the image, you go to Conversion. And now it's the tricky part. You have to set up this thing right to make it basically you have to set up things right, otherwise it'll be just some weird lines and some other stuff. So it will not display image properly. So first things, you have to go to preset, set the monochrome. Then you have to again select monochrome. Don't change any of this. Main scan direction, top to bottom, forward. Then go to image tab, split rows have to be selected, block size 8-bit, little endian. That's it. Now click show preview. It will show your image like this one, and there is your data stream. If you see something weird like this one, you can set up and prepare to edge, because while using diffuse editor, you can, with little dots, you can make a grayscale image appear on your monochrome screen, and I will show you that at the end. So right now we're going to just select edge. Let's go try now. As you can see, no weird dots nor anything. So now we have copied the whole thing. We are going to put that into Arduino. Just a second. I need this, or I can show you how easy it is from the start. Okay. Okay. Nope. Okay. Well, it's much more. I'm not used to MacBooks, so.
Okay, there you go.
Thank you. So first of all, we're going to write include ah okay. I'm sorry. Include.h. So we will include our library, but we also have to make a separate file for our image. So we go to Shift. We're going to press Shift, Ctrl and N, or maybe not. Yeah, you have to go this way. And we'll make name, for example, image.h. It's important to put that .h because otherwise it will make an Arduino.ino extension. And now we have to make array. So to make an array, you have to know which type of data you need. And we need static const uinit it's T. So now we pick a name, for example, picture 1, and make it array equals curly brackets, and now we just paste the code. Bam. And just at the end, semicolon. Don't forget about that. Okay, now we have to include this file into our program. So include image.h. Okay, that's it. We include our image, so we can use this array in our main code. Now we're going to make an object, plate display one plate 1 bit. So we are basically selecting that from the start it will start working in 1-bit mode, so only 2 colors. Display.begin display. So we are initializing the library by display.begin, display.draw bitmap. Now this is the function that will take that whole data and convert it into image and store it in the RAM. So first is the position where we want to put it. So I don't know, 100, 150. So these are X and Y coordinates. Next, we have to put the name of the image. So these are picture 1. And the resolution. If you're not sure about the resolution, LCD image converter can help you. And it's saying, nope, it's saying it's 300 by 324, and you just write that 300 by 324. The most important thing is the resolution of the picture that you want to put it on the screen should not exceed 800 by 600 because this is the resolution of our screen. So if we do not have any scaling, downscaling, or anything like that.
Okay. You got a typo right here. In an image.h, it's not a picture.
Oh, thank you. I didn't see that.
Picture, okay.
Okay, now we have to clean the display. Even though we are starting from the beginning, you have to clean the display because, as you can see, it's not powered on and the image remained on the screen. So we have to clean everything that was previously written on the screen. So clean and display.display. That should be it. Let's try compile it. And we won't. No.
Yeah, okay.
And we will try to upload it if it's compiled correctly.
So right here we have experimented with few versions of libraries, and I have one, and there's different one. So
yeah, on this version you have to also set the color. So we want our picture be in black. So every pixel, every bit in the data array means 1 pixel. So if the bit in data array is 1, it will be colored in this color that is set right there, and that's black. If it's 0, it will skip it. Now we'll try to recompile it and try to connect it. Let's give it a shot. So as I can see, we can connect.
Well, it takes some time because
Yeah.
the ESP core. So as you can see, it's quite simple to put your image on the screen. You need I might say a dozen line of codes, but it's not even that much.
Yeah, it's just how many? 1, 2, 3, 4, 5, 6, 7 line of code, and yeah. So it's uploading. The upload will take some time because it's a big picture. And let's try to power it up and see what we get. So the image is reversed, but we can fix that. It's in LCD image converter. So you can make just a second, inverse. So when you set to inverse, your picture should be inversed.
No, this one just inverts the colors.
Yeah.
Yeah.
And now you just go select all, copy, go to your Arduino IDE image. You just remove all this bunch of code. Okay. Delete it and paste it. And now you should re-upload it, and the image should be uninversed.
There are also other tools to convert images to these arrays of bits actually, and there should be some online available ones. We also have one in preparation, so it should be available by the time you receive your ink plates. So it should be a bit more easier to work with.
Because this tool is for all kinds of displays, so not only for e-papers, but as you can see, the image is on the screen. I can restart it to show you how it looks when it refreshes. Yeah. So as you can see, it's very easy to program the picture on the screen. Now I will show you how you can easily, so this is the 1-bit image, only black and white. I will show you now how easy it's to convert that into grayscale. So how easy is to print the grayscale image on the screen. Again, we are using LCD image converter, but now in a different settings. So I'll remove this card, new image, and again image. You go to image, import, you'll find the image, for example this lighthouse, and again options conversion. Now you have to select grayscale, again top to bottom, forward, go to image, split rows, block size 8 bits. This is very important. Sometimes is by default selected on 60 bits, so you have to choose 8-bit and of course little endian. When you're done doing this, show preview. Again, you can see your picture right there in grayscale, and now you just copy this whole array. Okay, now back to the Arduino. Again, we can use the same array for that. We just remove all these things. Okay. And just paste this code. Okay, so we have to change our code a little bit, but not too much. So first thing, because we are using grayscale, we have to switch to 3-bit mode. And because this picture is resolution 800, okay, 800 by 600, so it will fill the whole screen. We have to put the start location 0, 0, and that's it. That's it. Yeah, also you have to remove this and draw bitmap 3-bit, and let's try to compile it.
So as you can see, it took minimal changes also to change the image and to change the mode. So right now we are in a 3-bit mode, which will show the image as grayscale. So we are going to show it's quite similar to the image of the street that you have seen before, but the process was shown to you right now. Okay, so it's blinking, means uploading.
It can take some time because the bigger the picture, the of course the greater the size of the. Okay, something weird happened. Maybe because
we moved ours a bit. Yeah.
So we have. Yeah, this is old version. So yeah, we thought it was good idea to make something like this. No, it's not. Okay, and yeah, start. So it's very important to do this piece of code. I forget to tell you that. Okay. By writing this piece of code, you're basically telling that you want your image to be stored in Flash, not in RAM, because there you go. So as you can see, it's very easy to just program this picture on the screen. I will again restart to show you it's not some fake, I don't know.
Yeah, and a very good feature of an Inkplate is its speed. So this is in a grayscale mode, and you can see how quick it is when refreshing the contents of the screen. So it's actually, I think, 1.2 seconds right now.
Yeah, something like that. It's not great. It's not greater than, I think, 200 milliseconds, something like that.
Yeah, for a 1-bit mode, it's very quick. You can even achieve like 4 frames per second.
Yep.
And it's quite crazy for a paper display. It took a lot of time to get to this point.
But also a nice feature of the Inkplate, it also supports partial updates. The partial updates are not currently supported, so the version of library that supports partial updates is still not available on the GitHub. But yeah, our Inkplate also supports partial updates, and partial update takes the same amount of time. I think the same amount of time, like a classical update. We have example right there. David powering up. Okay.
So right here we have a display which is a bit bigger. So it is 9.7?
9.7, yes.
9.7 inch.
So it has a resolution of 1200 by 800 and something.
Okay, so partial updates actually means that you can update only parts of the screen without doing the whole refresh and flashing the screen while deleting the old contents. So you can get like partial changes of the screen. Right now it's of course just a prototype to show you that it's capable of. So you can see some ghosting, old lines, but it's kind of normal. This can be fixed a little bit, but in a partial update mode you will always have a little bit of ghosting. And also
many commercial ebook readers have also partial update, and when you do partial updates they have a lot of ghosting, so this is normal thing for e-paper display.
Yeah, so as you can see, this is a prototype, and a bit later Borna will show you some other ones as well, so that we have in development right now. So there are more things coming from us in a e-paper area.
Yeah,
but this is quite good looking one because of its size. It's really huge.
Really big, yeah.
I don't know how to show you the size.
Okay. So we can compare it to classical ones. So as you can see, yeah, it's pretty big.
Okay.
Now I will show you. Now David will show you how you can use the Wi-Fi functionality, because ESP32 has and Wi-Fi and Bluetooth. So there you go.
Thank you. So just a quick demo, since we already took some of your time. We have another example here, which basically uses the Inkplate library again, and it uses, probably familiar for most of you, the Wi-Fi library for the ESP32. So we used ESP microcontroller because of its Wi-Fi connectivity. So you can very easily get some data from the internet and show it on the screen. And that's exactly what we did right here. So we have connected to a Wi-Fi and set up just some basic stuff like the correct SSID and password. We are using Inkplate in a 1-bit mode, and we just did some connection to network. You will see it. And the main part of code is this function get data and update screen. So what we did is using the ThinkSpeak. It has a cool option, so you can use web scraping to create API from basically any web page. So we took our crowd supply page and took two parameters from it: the money collected and the number of units which have been sold. So we have like two APIs. It's a very simple example, but you can use basically any API that's out there. And using the Wi-Fi library and HTTP client or HTTPS client, you can get any kind of data from any kind of API service. And so we get those data, just get string like from a HTTP response and put it in a char array or a string. And later on in the code, we just show that string on the screen. So what it actually does, we have a live update of the current collected money and collected and sold number of units on an ink plate right here in the office. It automatically refreshes every 10 seconds, so we can always know the exact amount and celebrate on every new baker. So I'm going to upload it right now to demonstrate you.
I hope it will successfully connect to our Wi-Fi, because the signal strength is not that great.
Okay. Yeah, so as I said, you can use it for any kind of API. For example, you can get some info that you will regularly check, like your email on the screen or calendar for the day, or maybe even you can get your number of YouTube views of subscribers or something that's important to you. Or further on, you can get, so maybe you don't even know, maybe a lot of normal web pages have their API services which you can use to get data, or you can do something like with it to create your own API. Okay, so we are trying to connect right now.
Yeah, the signal is not that great. So this is how looks when you don't have a partial base. So you have to flash it every time you change the content on the screen. Yeah, the signals, it's not that great around here. Yeah. Maybe with some external antenna module. Do we have one? Yeah, we have right there. So
we are going to use an external antenna because this module used right now, it's using external antenna, not a PCB one, but Inkplate. The production version, it has a PCB antenna.
Yep.
Okay, so while Borna sets it up, I'm going to talk a little bit about further versions of the Inkplate. So as we have shown already, there are a few more coming. The first one, I'm going to just show it quickly again. It's the big 9.7 inch e-paper display with even higher resolution and kind of similar refresh times like Inkplate 6. There are also very similar thing, just going smaller in size. So this one is 5 inch,
but it has the same resolution of this bigger one.
Okay, so you got a smaller diagonal but high resolution. So the images are pretty much looking good on them. And the third one, this is very cool one for us and interesting. So you can see a lot of connectors hanging from this one. So this is actually a 6-inch one.
Yeah, 6-inch one, but it has a much greater resolution than this one that we are currently using.
Yeah, so you can see actually this is the Inkplate 6 picture on it, and it ends right here. So these are all new pixels that you get with this size. So at the same size, you again have the bigger resolution. And also you have two extra connectors. First one is for the touchscreen. So there's a touchscreen on this panel which you can use for your own projects. And the second one, okay, this one is
this is for e-paper, but here's a little.
The third one at the back, it's a backlight. So this one has a touchscreen, backlight, and a big resolution on a Cintiq display. So these are some of 3 future versions that we are expecting to launch after the Inkplate 6.
Yeah, it's very bad signal around here. We cannot get to connect to the Wi-Fi. Too bad. Yeah, I'm trying, but nope.
Okay.
So I forget about. Well, it's connected. No, it's not. So I just wanted to show you one more example that I forgot. So in 1-bit mode, you can use. In 1-bit mode, you can create grayscale pictures by using something called dithering. So dithering is the fact when on certain area you have, for example, more black pixels than white, and from the distance this area will be appear to you gray, dark gray. But if you have, for example, in the same area more white pixels than the black, this area will appear like more light gray. And if you, of course, you have all white pixels, then this area will appear white. And this is natively supported by the LCD image converter. So you can very easily do that. So again, we are going to fire up our LCD image converter. So again, the procedure is the same. You fire up LCD image converter, load up your image, go to options, conversion. Now you'll choose on the grayscale image preset monochrome. Monochrome, diffuse dither. Again, top to bottom, forward, image, split rows, box size 8 bits, little endian. And we are going to show preview. And it can take some time to convert
Depending on the computer.
Yes, of course we have to set to inverse. Yeah. Now show preview. Don't forget to put inverse right there.
Okay, well it does. This one finally got this signal, so you can see that actual campaign status is now shown on the screen and it refreshes every 10 seconds. So you can see that right now the current number of ink plates are 231, so it's actually live data showing from the website. So this is a quick example how you can use no problem. How you can use the Wi-Fi to get data and show it in a real time on your display.
Okay. Now it showed us preview of the image. As you can see, there are a lot of dots, black and white dots that make up the image. The image now it's look kind of blurry and everything, but on the screen it will look very cool. So again, click here, copy, select all data, copy data, go to Arduino, we'll select, nope, I think it's wrong example, yeah.
Okay, so we are going to open the one we have worked on. It's in a sketchbook and should be today's date. Yeah, it's this one.
Okay. So again, we are going to modify this image.h file. Again, we are going to click here, select all, and delete.
Yeah, so maybe someone was not watching from the beginning. These hex numbers are basically the image data that we have used LCD to image converter to make, and it just shows which pixels are active and which are not.
Yeah, so 1 means that the pixel is active and 0 means that pixel is not active. Okay. And now we're going to go back to the main screen, so our program. And we'll again come back to 1-bit mode and modify this function. So classical draw bitmap and add color, in our case black. And that's it.
Yeah, so even that dithering will show image like it's it has some grayscale, it's actually just black and white image because it's just white and black pixels made in the way that make it appear like it's not just black and white. So 2 options to show the picture with some color are the dithering and the grayscale.
So someone will ask why to use this dithering mode. I will call that mode. The reason is that you can use partial updates on this mode because partial updates are currently only supported on 1-bit mode and not on the 3-bit mode because they are very, very hard to develop. And here we go. So as you can see, if I go very, very close, you can see individual pixels. And if I go more further, you'll see that the image appears to be in grayscale. So pretty cool and pretty neat feature that LCD Image Converter supports.
Yeah, for some I even discussed that, which shows the better picture, the dithering on the grayscale mode. So if you're looking at this from some distance, it looks really like a grayscale, and you cannot see anything. But from a quite a close distance, you can see actually some dots. But it's visually, I think it's still okay.
Yeah. For me, it's much more beautiful and good looking picture than a classical 3-bit mode. But yeah, only if you look it from some distance.
Yeah, it's a matter of preference, I think.
Yeah. For example, I will use this mode for some I don't know, picture frames.
Yeah.
It's very good for picture frame because you'll never go too close to the picture frame and looking at the picture. So picture frame will be on, for example, your table, and you'll look at it from distance. And with the distance, it will appear like a real grayscale image.
Yeah. So okay, so we have grayscale image, and there's a dithering image. So maybe you can do some of judgment yourself. I'm going to try to show you the best I can. But I think you could agree it's quite similar, and both are good looking ones. Yep.
Yeah. They are both great.
So
it depends on the application that you want to do in the project.
So maybe we could give you a short overview of the things we have gone through this almost an hour. The first thing is probably to talk about the simplicity, which is the main idea behind the whole Inkplate project. So after seeing what's available and testing it ourselves as a makers, and I would say also professionals who are doing the electronics development, we have seen that the boards are not satisfying at this point of simplicity, because at the hardware side there were a lot of work in order to make them work. You would need external boards, like external adapters for these special kind of connectors, and you will need maybe special processor, and the software support was not good at the other side as well, because it was even either partially supported, or it was just some code, and good luck with that. You can try it, but you never know what you're going to get.
We have a right here one. We are trying to power this thing up, and it's not very easy. So yeah, for example, this, I think, use UART communication, and the documentation for this, it's very, very bad. So yeah. I think the main point of our Inkplate is definitely easy to use. So and it works straight out of the box. So it has a library support. It has library software support, and we have also hardware support. And we also have our support, so you can contact us if you have some problems with the starting the library.
Yeah, exactly. So that's quite a good thing but we haven't mentioned it yet. So the technical support for the product. If you have any issues, there is a support forum which we are waiting to answer your questions and help you with your problems. So the software-wise, we also didn't mention one thing, and that's MicroPython, which many of you like to use. So the Inkplate will support the MicroPython as well. So all functions that you have seen through the Arduino are going to be supported and working through MicroPython as well. So it's basically available for any platform that you used to work in and you know how to use it. Also, there are many questions. Is it going to work with the Raspberry Pi? Since it's completely a different platform, we have thought of special Inkplate mode, which we name slave mode. Because the device is going to be in a special state waiting for commands through I2C. So at the time when you receive the device, it's going to be programmed with a slave mode code. So if you want to use it with a Raspberry Pi or virtually any other microcontroller, you can connect it with the I2C either via the pins at the bottom of the board, so we didn't mention those either. So there are many connections for you to add your own boards and stuff sensors. And there's also EasyC connector, which is basically a QUIC of SparkFun's QUIC connector equivalent. So you can use I2C videos to connect them extra easily to some other board. And in a slave mode, okay, Borna will tell you a little bit more about
So the reason why we're using slave mode is because these displays that we're using are not SPI, not I2C, not some kind of classical parallel communication. This communication protocol is dedicated for e-paper displays. So the same communication protocol can be used on this display, on these displays, on these smaller ones, and it's a very, very complicated thing to do. And even though the displays are very slow to update, the data throughput has to be very, very big, and Raspberry Pi cannot do that kind of data. Maybe on SPI, but then we'll have to convert SPI to parallel and all kind of stuff. So it's much easier to do this way. So basically, you'll just send from your Raspberry Pi simple commands. For example, some command for, I don't know, draw a pixel and something like that, and you will just draw a pixel on your screen.
Yeah, so basically the functions you have seen in this code, like basic set something to the screen functions, will be available through this I2C mode, actually the slave mode. So you will be able to put everything on the screen, even the pictures, but it's going to be slow because of I2C, but it's doable. So it's a kind of an option or a backup for your
but we also we are working on it that you can also put the pictures on your SD card. Classical bitmaps, we are also trying to implement that you don't have to convert to be a grayscale, so you can put color image and our software will handle conversion. We are trying to do that, but it's still in development. So yeah, you could basically load images on your SD card and just say from Raspberry Pi to ESP32 load, I don't know, image 1.bmp to the screen, and we'll show the image on the screen.
Yeah, so the slave mode is going to be quite easy to use, and the most important of all is going to be it's going to use all the InkPlay simplicity, but it's going to make it available to other platforms. So you got all the logic for the paper display, you got the power supply, which is especially special. You got the SD card reader, and you can use all other parts of the hardware, such as battery and battery charging, in order to make this work like very simply. So with the Raspberry Pi, you need like 15 minutes to make it work.
Yep.
And the second question that we have received quite often is there a 3D printed enclosure, which is a completely logical question for such product, which is, by the way, extremely fragile, and that's why it's glued to the PCB. So every ink plate is going to come with the standoffs, like on this one, either plastic or metal ones. So when you put it on the table, it's not touching the electronics, and the connectors are not touching anything and not being damaged.
Yeah, the day we forgot about mentioning that the connector, you have to be extremely careful with this connector because it's a very fragile thing, especially this flat cable. We try to protect it somehow with this cut out, but again, it's not that easy to protect this very, very fragile piece of thing.
Yeah, so just every flex board, you have to be careful with it. Yeah, and that's why the standoffs, and that's why the casing is quite a good idea. So we are going to publish a casing or our crop supply campaign as an update in upcoming days. So we are going to prepare a 3D printed one, which is going to be quite simple to print because it's
just a box.
Yeah, it's very not some special edges or stuff. So
but also there will be dimensions, so you can, if you want to create your own.
Yeah, we are going to provide a whole technical drawing of the board and the whole product, so you can make your own board or customize our own if you wish. But there's going to be an option, so you can just download it, put it on a printer, and get it 2 hours later. So yeah, it's going to be available. Do you guys maybe have some other questions for us?
Yeah, we don't see any questions.
There's a chat on YouTube, so
No.
if you have any now, it's good time. Either there's always a chance to ask us some questions on our crowd supply page. At the bottom of the page, there's button Ask Radionica a technical question, so you can click here and write us everything, and we'll receive your email and get back to you as soon as possible. So feel free to ask any kind of stuff. On this crowd supply page, there are also some examples that we have prepared for crowd supply, like a current stocks price, or a weather station, or your daily calendar, which you can put on your work desk or something and always have a glance at. Maybe even email is a good idea. For me, I thought of putting my to-do list to have it always available with me, and probably you will have some your own kind of idea which you can make using the Inkplate. So you can even use it for like an ebook reader if you wish. If you have programming skills and want to do it, it's also possible. Yeah, okay. So if there are no extra questions, I would like to say thank you for everyone who has been today with us. Hopefully we have shown something useful for you and maybe give you a better idea of what the product actually is. As I said, feel free to get in touch with us at any time. We'll be waiting for your questions. And in either case, continue to look at development of Inkplate. As we mentioned, there are going to be more different versions, and hopefully even better software support. I believe the community will also make some kind of software support, and I believe we'll see a lot of great projects made on Inkplate.
I hope so. Also, if you know some people that are interested in this project, please share this crowd supply link, share this YouTube link if you know people that are interested in Arduino, in display technology, in e-papers. So yeah.
Okay, there's one question. How about low power modes in the ESP32? So the standard ESP32 power modes are supported.
Yes.
And available through Arduino IDE. The one that we have talked about, it's the lowest consumption sleep mode, and that's the one we have mentioned that it's available at 25 microamps.
Yeah, yes. So this is a deep sleep, but you can also use a light sleep. I think it's also supported by Arduino, and I don't think Arduino have a moderate sleep. I don't think so. So I think it has maybe 2 or 3 modes, but all low power modes that are supported by Arduino IDE are also supported by our Inkplate.
Yeah, exactly. So basically every other function that's working for ESP32 in Arduino, you can use it with an Inkplate since it's based on ESP32 core for the Arduino.
Yes.
Okay, guys. Thanks for your time. As I said, hopefully we have gave you a better idea. Please share about the project, and hopefully keep in touch. Maybe meet you at some maker event somewhere at some part of the world.
Yeah.
Yeah. Okay. Thank you, and bye bye.
Bye bye.
Bye bye.